This video is on finding volume using the double integral method. So here I have the function z equal to 4 minus x squared, which is this yellow surface right here. And then I also have the plane y equal to 1.5x, which is this plane right here. And I want to find the volume this above region R. This is region R right here. So here's the graph for the function z equal to 4 minus x squared. And so right here, here's the xz plane. So this is the x-axis and this is the z-axis. And so this is the xz plane, which is the plane y equal to 0. And so to draw this graph, what we can do is draw the function z equal to 4 minus x squared on the xz plane, and then from here extend it along the y-axis this way and then also this way, and then we get this surface function for z equal to 4 minus x squared. And then the plane 1.5 y equal to 1.5 x. So notice that 1.5 is the same as 3 over 2. So the slope for this line right here would be 3 over 2. So we would go up 3 and then over 2 on the x-axis to get this point on this line. And then I want to find the volume over this region R right here. And so on this side, the solid is bounded by the xz plane, and then on this side, the solid is bounded by the plane y equal to 1.5x, and then at the bottom is bounded by region R. So this is what the solid looks like. And so here's the solid that I want to find the volume for. Before calculating the exact volume for this solid right here, what I want to do here is approximate this the volume of this solid with the rectangular prisms. So what I'm going to do is I'm going to divide this region all right here into many rectangles like this. And so the distance from here to here is 2 and 4 rectangles right here. And so the width of each rectangle will be 0.5. And then the distance from here to here is 3. And there's 6 rectangles right here. So the width of each rectangle is also 0.5. So what it means is that for each rectangle, the area will be 0.5 times 0.5. And so I'm going to create rectangular prisms for each rectangle that's inside of region R, or part of it is inside of region R. And so here's the rectangular prism that's corresponding to this first rectangle right here. And then to calculate the height, what I did was I chose the point that is right in the middle of the rectangle right down here. So this is 0.5, this is 0.5. So I just picked this point right here in the middle, which is 0.25 for the x and 0.25 for the y. And then to calculate the height of this prism, we just use the height function z equal to 4 minus x squared. And then that will give us a height of 3.9375. And then to calculate the volume, it just be the area of the rectangle right here, and then times the height, and we will get 0.9843 for this first rectangle right here. And then here's the next rectangular prism. And then notice that many of the rectangles here, only part of it is inside the region R. So here obviously we're going to be overestimating the volume of the solid here. And so here I have a total of 16 rectangular prisms, and the volumes of the 16 rectangular prisms is 9. And so obviously the volume of this solid right here is going to be way less than 9. And to get a better approximation, what we can do is fill this region R right here with smaller rectangles. That means we get more rectangles this time. And here we get about 48 rectangles, and then the volumes, a typical rectangular prism would look like this. And then the volumes of the 48 prisms, rectangular prism, is about 6.078. And here I'm filling region R right here. I'm dividing it into even smaller rectangles. So in here, inside of region R now, we have about 192 rectangles. And then the sum of the volumes of the prisms is about 6.019. And so as the number of rectangles increases, we're going to get a better and better approximation of the volume of the solid. And so here's a summary of what I just did. When I divided this region R right here into approximately 16 rectangles, then the sum of the volume of the prisms is 9. And then when I divide it into 48 rectangles, then the sum of the volumes of the prisms is about 6.078. And then right here, I have about 192 rectangles inside of region R, and the sum of the volumes of the rectangular prisms is about 6.01. And therefore, if we want the exact answer for the volume of this solid, then we need to allow the number of rectangles to go to infinity. And so delta y here would be the length of the width of the rectangle along the y-axis, and then delta x would be the width of the rectangle along the x-axis. And then f of x sub y here, f of x sub y sub y is the height of the rectangular prism. And here we have an infinite number of rectangular prisms. And if this limit here exists, then we defined it as the double integral that looks like this. And now let's find the volume, the exact volume of this solid right here using the double integral method. And to get the exact volume, we can use what the dy dx method, or we can do the dx dy. So in this case, I chose to do the dy dx. And so since we do dy dx, then the constant bounds for x, for region R right here, will be constant, and so it'll be between 0 and 2. And so x will be between 0 and 2. And then the bounds for the variable y, the y will be variable for this region R right here. And so this region R is bounded by this line and by this line, and also by the line x equal to 2. Now this line right here is the line y equal to 0, and this line is the line y equal to 1.5x. And so to set up the double integral, the x will go from x equal to 0 to x equal to 2, and then the y would be this line, which is the line y equal to 0, up to this line, which is the line y equal to 1.5x. And then the height function, that's the function z equal to 4 minus x squared. So we have 4 minus x squared. And to evaluate this double integral, we just do the inside integral first. So this is the inside integral. And notice that there's no y here, so this entire expression is constant. since we're integrating with respect to y. So we get 4 minus x squared times y. And then we need to evaluate from y equal to 0 up to y equal to 1.5x. And this is what we'll get. And therefore the volume will be the integral from 0 to 2 with this expression. And then if we evaluate this expression right here, we'll get 6. And so the exact volume for this solid is 6. Recorded a few moments ago when I feel that when we divided this region all right here into 48 rectangles and then find the volumes of the corresponding rectangular prisms, we got 6.078. And then when I fill this region R, read this region R right here into 192 rectangles, then the sum of the volumes of the prisms was 6.01. So we can see that they're very, very close to the exact answer of 6. And so in summary, the volume of this solid right here is 6. And that's the end of the video.